All right, I'll be going over the double placement reactions from last week next. Number one, we've got AgNO3 reacting with K3PO4. Now, in a double replacement reaction, the cations switch partners. So it can be helpful to go through and figure out what your ions are first. Here, silver always has a +1 charge in the back of the periodic table. Nitrate, NO3, is -1. K has a +1 charge because it's in group 1, and phosphate, a -3 charge, it's polyatomic. So what happens here is that our cations, our Ag and our K, switch. They are doubly replaced. So I end up with my Ag plus bonded to my PO4 3-, which gives me a formula, Ag3PO4. And then my K plus ends up bonded to my NO3-, and I get KNO3. Now, those are the formulas of my products. Those are determined by those charges, not by anything else. Now, it's time to balance. So I like to balance polyatomics first. One nitrate, I'm good. One phosphate here, one phosphate here. That looks good. Now silver, one silver here, 3 here. I'm gonna fix that with a 3 right over there. But when I balance that out, I now have 3 nitrates. So let's fix that over here. Put a 3 right there to give me 3 NO3s. That also gives me 3 Ks here to balance up my 3 Ks here, and I am done. That is the correct balanced equation for number 1 on your double replacement reaction worksheet. Let's look at number 2. I have got NaCl reacting with Ki. So again, double replacement, cations and anions switch. Cation is Na plus bonded to Cl minus. K plus and I minus over here. So for this reaction to work, my cations swap places. So on the product side, the Na plus ends up bonded to the I minus, giving me NaI. And the K plus ends up bonded to the Cl minus, giving me KCl. Got my formulas of my products done. It's time to balance. And if you look it over, you'll realize they're all already balanced. In number 3, H2SO4 is reacting with KOH. So in a double replacement reaction, we need our cations to switch. My cation here is H plus. There are 2 of them because it's bonded to sulfate, which is SO4 2-. Then I've got my K plus bonded to OH minus, potassium hydroxide. So for this to work, I do some swapping of my cations. The H and the K switch partners. So in the products, the H ends up bonded to the OH, which you would think would give you HOH, right? But we write that as H2O. It's water. Whenever an acid reacts with a base, you're going to get water. And then our K plus is bonded to our SO4 2-, which means I need K2SO4 for those charges to balance out. Now that I have my products, it's time to balance. Polyatomics first. SO4, SO4, looks good. I've got a hydroxide here, but because we write it as water over here, it's hard to balance, so just balance those separately. So from there, I have got Ks, 1 K here, 2 K here, which means I need a 2 right there to balance those Ks. I now have 2 hydrogens here and 2 here, which is 4. So to get 4 out of this, I double down there. I have 2 oxygens here. I'm going to ignore these because I balanced that sulfate, that SO4, as a whole. So I just need these O's and these O's to balance, which they do. There's 2 on each side. And if I get rid of my scratch work, that would be a complete balanced equation for number 3. Number 4, I have NH4Cl plus NaOH. helpful to figure out what our ions are. So NH4 plus is our ammonium cation, Cl minus, the chloride anion. And then I've got Na plus because it's in group 1, and I've got OH minus, hydroxide. So we're going to take our cations and we're going to switch partners. So the NH4 ends up bonding to the OH. NH4 is +1. OH is -1. So I just get NH4OH, one of each. And Na plus ends up bonded to Cl minus, giving us NaCl. And if you look that over, you realize it is already balanced. Number 5. KOH plus, what do I got? HNO3, nitric acid. In order to switch them, let's figure out what our cations and anions are. K plus and OH minus, potassium and hydroxide. H plus and NO3 minus. Take your cations, take that K, take that H plus, swap them. So in the end, my K plus is bonded to NO3 minus. One of each will balance that out. And my H plus is balanced to my OH minus. We saw this once already. We don't write it HOH. We write it H2O. It's water. And if you look that one over, you'll notice it's already balanced. Number 6, AgNO3 plus MgCl2. Figure out what your cations and anions are. I've got silver, which is always +1, bonded to nitrate, NO3 minus. Magnesium in group 2, it's Mg2 plus, bonded to Cl minus. And then to figure out my products, take your cations, switch them. So in the end, the Mg2 plus ends up bonded to the nitrate, which is NO3 minus, which means I need 2 nitrates to satisfy that 1 magnesium. And then I end up with Ag plus bonded to Cl minus, which is just AgCl. And now I need to balance. Polyatomics first. 2 nitrates here, only 1 here. It's like that. 2. 2 silvers here, which means I need 2 silvers here. 1 magnesium, 1 magnesium. 2 chlorides here, 2 chlorides here. That is my balanced chemical equation. And the last one. K2SO3 reacting with HNO3. Now, this one's a little bit tricky. K, we know, is always +1. It's in group 1. If there are 2 of them, that means this SO3 must have a 2- charge. It's sulfite. It's on your big list of polyatomic ions. H plus here, NO3 minus here. To figure out our products, take your cations and switch them. So the K ends up bonded to the NO3 minus, giving us KNO3. And the H plus ends up bonded to the SO3 2 minus. Get that out of there, that's old. Which means I need 2 H's to balance out my 1 SO3. And then this needs some balancing. 1 SO3 here, 1 SO3 here, 1 NO3 here, 1 NO3 here. So my polyatomics look good. But I have 2 Ks here, which means I need 2 Ks here, which now means I have 2 nitrates. So I'm going to put a 2 there to balance my nitrates. And that's also going to balance out my hydrogens. 2 on the left, 2 on the right. That is my balanced chemical equation.